Currently, there is an organism that is putting our freshwater resources at risk. This organism is called a cyanobacteria, which you may have also heard referred to as blue-green algae, and it forms these massive algal blooms in lakes and also has the potential to produce a harmful toxin, which doesn't only harm us, but also our pets, livestock, and aquatic life. As recently as 2016, in the city of Toledo, Ohio, nearly 1 million residents went without clean drinking water for an entire weekend due to one of these blooms caused by a specific cyanobacteria called microcystis. But microcystis doesn't only bloom in Ohio. In fact, it has been recorded on every continent in the world with the exception of Antarctica. But what's even crazier is that scientists don't know why these blooms occur. In the past, researchers have examined abiotic or non-living factors, such as warm temperatures or nutrients from fertilizer runoff, as being the culprit for why these blooms become so detrimental. But no one has studied the living factors. What if, rather than one single organism, it's rather a complex assemblage of a variety of different types of bacteria that work together with the algae that make these blooms so prolific? I am taking the field in a new direction by using bacteria that I have isolated from entirely different sides of the globe. I traveled to both Lake Erie in Ohio and Lake Tai in China in order to collect samples during an active algal bloom. I then isolated the bacteria from the samples in the lab, and I used these bacteria to grow together with the algae to monitor their growth over time. I am also looking at the transcriptomic data so that I can assess what genes are actively being expressed by the bacteria that are helping promote the growth of the algae, which is important to know because if it's occurring in the lab setting, it may also be occurring in the field. The data generated by my research is critical for making informed policy decisions that take into account both the living and non-living factors to these blooms. Additionally, with the current rate of global climate change, it is imperative that these issues be addressed immediately.